Hi, I'm Natalie Weisberg,
And I'm Jonathan Cruz.
and we are filming for mini project number 3. So we are doing it on fusion, which has been our energy source, and I actually work at the fusion lab on campus. So we're going to start by walking around the fusion lab and sort of showing some of the technology that we've been talking about in our essays and some of the current initiatives.
After that, we're going to head to the quad and get some public opinions. We want to know what people think about fusion, whether they have a background in it, being a nuclear engineering major, or just anyone, just to see what they think.
Yeah, we talked a lot in our initial mini project about how current public opinion of nuclear is kind of rocky and that's spilling over into fusion. So I guess we just want to kind of go out there and field some data, see how data that we read about translates into real life, and also talk to some people in the nuclear major about where they see the industry going.
So this is Hydra. It's our campus's very own research vessel for fusion energy. It doesn't produce any energy, but we use it for research on using liquid lithium as a first-wall plasma-facing component. And you can see the design really looks like a tokamak, but it's actually a hybrid tokamak stellarator. And of course, this is an MCF. So we can come around back and I can show you guys where we load the lithium. So this is the transfer arm right here that we use to load lithium into Hydra. So it has a disc that we place it in, and then it inserts, and then we use that lithium as the first wall plasma facing component, and it really helps to confine the plasma. This is Helm. Helm is used to get data on the difference between using tin or lithium as a first wall plasma facing component. Current trials have only been done using tin, but from our findings, tin is not suitable as a first wall plasma facing component. Basically, up there is where we have plasma, and we raise up the sample up there, and we have tin up there, and we found that it's just not good in a hydrogen plasma. And this is Icarus. It's also used for testing liquid metals, just on a smaller, more precise scale that can be imaged with an SEM. And it's very cute. So what you can see from this is that there's a bunch of different ways to investigate improvements for fusion technology, and it doesn't necessarily have to be really big like Hydra. It can be really small like Icarus. So I'm interviewing some undergraduate members of American Nuclear Society here. So how many of you are in the plasma concentration? Okay, wow, we've got a lot of plasma engineers. Could I get somebody from plasma to explain a little bit about what fusion energy is?
Fusion energy involves usually either deuterium or tritium colliding at each other, and for the price of a little bit of mass, turning into a lot of kinetic energy, which can be made into electric energy for people to use in the future.
And this is an opinion piece, no wrong answers, but what would be your guys' estimate on when fusion energy will become commercially viable?
A lot of jokes in the industry from what I've heard about fusion being viable in the next 20 years. It's always 20 years away. In my opinion, I feel like we'll get there very soon, at least maybe sometime after the next decade.
Thank you. That's a very hopeful estimate. What do you think are the major barriers to achieving commercial fusion?
I think one of the biggest barriers is just it's a very technologically advanced process. We're trying to replicate what's happening inside the sun but on Earth, which is very hard. I don't think that there's a shortage of labor. There's a lot of interest in nuclear, and so a lot of students are really fired up about fusion. So the only thing stopping us right now is time.
And I'd like to put in. I think another potential barrier is that fusion is still associated with nuclear, and there's a lot of bad connotations around that, and topics like these can get very polarized politically very quickly, And so while it's like very bipartisan, and if it stays that way, it'll be a lot easier to like get legislation passed and regulations and stuff like that.
Okay, so I am now interviewing a grad student in nuclear. And would you like to tell us, to the best of your knowledge, what is the major current barrier to achieving commercial fusion energy?
I do not concentrate in plasma and fusion, but in terms of getting to fusion energy, viable fusion energy, is finding a way to get to a positive output, a net positive output, rather than investing more energy in than we currently have. And the best way to do this is by ensuring that we have good blankets and tritium production within those blankets.
So here we are interviewing Piper. And Piper, what would you say is the number one innovation that we should be focusing on in the field of fusion energy?
Fusion energy?
I know it may not be your wheelhouse.
Yeah, not quite my wheelhouse. But I can can I talk about plasmas?
Yes, absolutely.
Okay, I think that people should be paying more attention to what plasmas can do for the environment. So for example, I'm using plasmas to degrade forever chemicals, which are really toxic. And there's a lot of other really cool environmental applications of plasma, and people should start paying attention to that more.
Thank you. That's a very good point. Reese, in your opinion, do you think that fusion will ever become commercially viable?
Possibly far down the line, but it seems like it's in its infancy right now.
Do you think that we'll be able, if it ever does become commercially viable, to get strong government approval on policies surrounding fusion energy, or do you think it'll always remain too controversial to really pin down?
I hope that it gains governmental approval. It seems like it would be more likely to than fission plants.
Thank you, Reese. Have you ever heard of nuclear fusion energy?
Yes.
What are your opinions on it?
I don't really know too much about it. I have heard about it though. I think Nuclear Club's like right over there. Is that you guys? Okay. Not too much about it. I know that like as long as you can like handle the waste and stuff, it's pretty chill. Hi, Hanif. Yeah.
Thank you. So this is an example of just an ordinary person and their knowledge on nuclear. Have you ever heard of nuclear fusion energy?
Yes. Yes.
What are your opinions on it, if any?
I think it'd be really cool if we could make it work. I know it's really difficult. We've been working on it for years, but if it could work, that'd be awesome.
True. So, have you ever heard of nuclear fusion energy?
Yes, I have.
What is your opinion on it?
So long as it doesn't kill me, it's probably going to be good for me at some point. Right now, not so much.
Yeah, that is a good opinion to have on it. So you would need to see more developments furthering it along, maybe more safety measures before you'd really get behind it.
Yeah, and I don't even know about the safety, but obviously they can't sustain it for very long right now, so it's still under development. So we don't know how long it's going to take, but once it happens, this could be, this could be a lifesaver, literally a lifesaver.
Yeah.
So.
Thank you. That's very useful. Okay, so I'm here with Allie and Elise, and we're going to ask them a little about nuclear fusion energy. So, what is your opinion on nuclear fusion energy?
I don't really know a lot about it.
It's got a cool name.
Yeah.
They both think, would you say you feel pretty cool about it?
I mean, I'm assuming it's like, I know nuclear is clean energy, so I'm assuming it's along those.
Clean energy. You hear that, folks? So, would you say that you are a supporter, or do you think that you need to know more about it?
I've learned a lot through you, so I'd say I'm a supporter.
We've got a supporter. So, You see, on this campus, seems like a lot of people feel pretty good about nuclear fusion energy. I am here interviewing Solar Car. Solar Car, have you guys heard of nuclear fusion energy? Yes. Okay. And what would you say your opinion of it is?
Seems cool and really confusing. I don't understand it, but it seems awesome.
Would you like to know more about it? Do you feel like if there was resources locally or at our school about learning more about fusion energy, would you take those resources and learn more?
Yes, definitely.
You heard it here first, folks. We need more local resources teaching about fusion energy. For example, did you know that we have a nuclear fusion laboratory on campus? No, many people did not know. It's only a block away from where we're standing right now. We need better education and resources for nuclear fusion energy on campus.
So the first people we talked to were people from the American Nuclear Society, and it was interesting to get their perspectives with a lot of them having a background in nuclear energy. So it was interesting what they had to say, and they were pretty knowledgeable about the topics, but some other people we talked to, they didn't know as much.
Yeah, like for instance, when we talked to Solar Car, all of them expressed that they want to know more about fusion energy. And especially, working in Solar Car, they're clearly part of sustainable initiatives on campus, and their work and interests tie right in with fusion, but they each expressed that they don't really know anything about it. All but one of them didn't even know that we have a fusion lab on campus. And so I think in general, there kind of needs to be more education on fusion energy and plasma in general, especially at our school where we're one of the leaders in innovations for fusion research. When we have a research vessel, I feel like we should be integrating it more, especially into general sustainable initiatives on campus. For example, last year was the first time that a nuclear organization on campus was invited to the Earth Day Quad Day thing, because before that, the school didn't consider nuclear technology to be sustainable. So there just seems to be a general lack of informing about nuclear on campus that kind of reflects the general lack of information on nuclear in society. But overall, we got really great answers from everyone. A lot more people knew about fusion energy than I thought they would. I kind of thought we'd go up to people and be like, have you ever heard of fusion energy? And they'd say no, but no one said no. Everyone had heard of it, which was good. I wasn't totally expecting that. So yeah, generally, I feel like there's a trend of people becoming more aware of fusion energy, and that's really important. Because we need more people on our side and we need more people on our team.
And we talk a lot about in our other projects the potentials of fusion energy, but regarding the education, it's important that the people that are going to be leaders someday actually know about this technology. Some people even in nuclear didn't know as much as we thought they would, so definitely education and just general knowledge is important for not only the innovators and future engineers, but just the general public as well to garner legislative support.
Yes, I hope that you enjoyed all of our interviews. I know I did. And I hope that you have learned something about nuclear fusion energy from our projects.
Thanks for watching.
Thank you for watching.